Let's start with the introduction. Differentiation is a process of finding the derivative or rate of change of a function. There are three basic derivatives in differentiation. The first one is algebraic function. D x power of n is equal ns power of n minus 1, in which n is any real number. The second one is trigonometric function, and the last one is exponential function. Why we use differentiation? We can find rate of change using differentiation. It enables us to determine the rate of change of velocity with respect to time, for example, which is acceleration. It is allow us to calculate the rate of change of s with respect to y, which is the gradient of the curve on a graph of y against x. Other than that, differentiation can help us to solve many types of real-world problems. To be clear, it can be applied in our daily life. Let's say we use the related rate.
Related rates. In related rates, we have to apply the differentiate method to find related rates. We use differentiation to find rates of one quantity with other quantity rate of change. As we know, rate of change always relate with the times. Formula for this related rate is df over dt. So in this formula, we use differentiate method. We separate the formula. First, we need to differentiate the functions. Then we need to differentiate the times. After finding both answers, we need to put it back in the formula of related rates, which is df over dx is time with dx over dt.
The basic solid figures. In mathematics, solid geometry was the traditional name for the geometry of three-dimensional Euclidean space. As for the practical purpose, the kind of space we live in. It was developed following the development of plane geometry. Stereometry deals with the measurements of volume of various solid figures, including cylinder, circular cone, truncated cone, sphere, and prism. Then, from the solid geometry, there is the three-dimensional space geometry, the sort of space we live in. It is called as three-dimension or 3D because there are three dimensions of the space that includes width, depth, and height. The properties of solids, which is a particular characteristics, have properties like volume, area of the surface, vertices, face, and edges. It is shown 6 common basic solid figures formula. Let's take a look here. Prism. The height of a prism is always measured perpendicular to the base plane. That's right, even if a prism is next to it or tilts an oblique prism. So the first one is rectangular prism. We often learn about the volume using rectangular prism, such as creating the prism from cubes, especially right rectangular prism. As long as you measure prism height perpendicular to the face, any face of rectangular prism might be foundation of it. The formula of volume rectangular prism is area of the rectangle multiplied with the height, the length of it multiplied with the width and the height. Then triangular prisms. A triangular prism has a base shaped like a triangle. To find the volume of triangular prism, the area of the triangle must be multiplied with the height. And the formula is 1 over 2 base of the triangle multiplied with the height and multiplied with the length. Let's move to the next one, cylinder. A circular cylinder is a prism-like figure that has a base shaped like a circle. The formula used to calculate the volume of circular cylinder is area of the circle multiplied with the height. Area of the circle includes of pi multiplied with the radius square with the height. Moreover, we have pyramids and pyramid-like figures. The height of a pyramid is also measured perpendicular to the plane of its base. The same formula for right and oblique pyramid-like shapes works because of the Cavalieri principle. Let's see about this rectangle-based pyramid. A rectangle-based pyramid has a base shaped like a rectangle. The formula used is 1/3 area of the rectangle multiplied with the height. Moreover, the cone, a circular cone, is a pyramid-like figure that has a base shaped like a circle. For this one, we use the formula of 1/3 area of the circle multiplied with the height. So 1/3 multiplied with the pi of radius square and multiply it with the height. So last but not least, the volume of sphere. It is pretty easy to calculate the volume of the sphere as it shows 4/3 pi multiplied with the radius cube.
We will move to the next part, which is the question part. I will show you how to solve the question with related rates. So, the question given that a tank with a metal slab has a width of x meter, length of 2x meter, and the height of 2 meter. Then, when the tank heated, the width expanded at the rate of 0.01 meter per hour, and find the rate of change of the surface area when the volume is 36 meter cube. So, from the information given, we could determine that the width expanded at the rate of 0.01 meter per hour is dx over dt. So, our dx over dt is equal to 0.01. Then, the statement is also gave us that the volume is 36 meter cube. So, V is equal to 36. Then, we can find the x value from the volume given. As we know, the formula for the volume of a tank or a cuboid or a cube is length times with the width times with the height. So, based on this question and this figure, we can know that the volume of this tank is equal to 4x squared. 2x times with 2 times with the x. So, indirectly, we know that V is equal to 4x squared. Just now we point out that V is equal to 36, so 4x squared equal to 36. Then we will make the S as a subject and we'll get the S is equal to 3. The next thing we need to do is find the area of this tank. Why? Why we need to find the area of this tank? Because the question asks us to find the rate of change of the surface area. So, we need to find out the area first. To find the area, the formula is length times with the width. So, since the question gave us a 3D figure, we know that everything we calculate will be double. So, to calculate the surface area of this tank, width times with the height plus length times with the width plus length times with the height. Then, multiply all of it with 2. So, we will get the area of this tank is equal to 4x squared plus 12x. So the last step is we need to find the dA over dt. How we know that we need to find what? Because the question asks us to find the rate of change of the surface area. So from that, we could know that the question gives us to find the dA over dt. So, to find it, dA over dt is equal to dx over dt multiplied with dA over dx. You can see that to find dA over dt, it have a relation with dx over dt and dA over dx, because after this, we can cancel both of ds, then we will get only dA over dt. So, dx over dt is equal to 0.01. We'll multiply with dA over dx, which is 8x plus with 12. the S over dt is already given in the question, but the A over ds does not. So how we can get the A over ds? Yes, a good question. So just now we calculate the area of the tank, right? So from the area we can get the A over ds. How? By differentiate it. So when we differentiate the area, we will get 8s plus 12. Then back to the first thing we calculate just now, we got the x value, which is s equal to 3. So we substitute the s value into this question. We get the A over dt is equal to 0.36 meters squared per hour.
For the conclusion, from what we studied before presenting this project, it is proof that we can apply technique of differentiation in our daily life. And I think that's all from us. Thank you!